Well, hi, good morning. Thank you for joining me in my shop here. Today is July 7th. Gray, rainy day, but the heavy heat is gone anyway. It'll be warm, but... Okay, so yesterday I replaced the filter capacitors, and with no surprise, the radio is actually operating now. It still has in it, four. There's four wax capacitors, five. We're all bundled here, right in this area, five of them. But they do appear to be in okay shape, but that doesn't mean much. And there's a few other different capacitors over here, which I suspect are replacements. 3 different types. But I'm not sure. So what I want to do with this radio now is put it through some tests and kind of judge the condition, its operating condition, with a little more refinement than just turning it on like I did yesterday, just hearing it operate. Incidentally, I've vacuumed off or dusted off the radio, so it's a lot less dusty now. But what's going on with this tube? How come it's white on the top? In fact, it's white on the top and white, a little bit white. It looks like. How come it's not black like this one? I don't know. just wonder about things. Okay, so I think the first test we'll do is we're going to check on the output tube grid potential. We can actually start by taking a look here. Now, so it's fairly likely that one of these capacitors is a replacement onto the grid of the output tube. Here's the output tube, and what is it? It's a I don't know. It's an I don't know yet. Let's just pop it out. I haven't gotten the schematic for this yet. This is going to be a 50C5. That's my guess. What is it? 50L6. Okay. 50L6. Just stick it back in. Okay, 50L6. We'll look in the book and see. Hey, who's got my book? Here's my book. We'll use this one. 50L6 right here. There it is. And the grid, G1 is 5, pin 5. I'm going to find pin 5 on the output tube. Let's see here. Pin 5 on the output tube. So let's count pins here. Okay, so there's the key. So this is 1, 2, 3, 4. This is 5. And you can see the capacitor is very different from these. So I'm willing to bet somebody replaced this. Now looking at the job here, you know, it looks... So this one has a replaced look to it on the solder job. And my coffee maker calling me. A little hard to see there. And I've wandered off with my flashlight. Okay, well, regardless, at this point, we don't need to know for sure if this has been replaced or not. It's a good looking, it looks like a good quality capacitor. What I want to look for is the voltage here. Now, what's happening here? I got this. Perhaps this is a grounded point. Okay, I'm not quite sure what they're doing here. Oh, this is a spare. This is a spare terminal. There's nothing in here. Okay. So what we've got is a little resistor off the cathode, followed by a large resistor. What are they doing there? And we have a massive solder job down here. Crazy. They've managed to solder these two terminals together. Why? So this is really why the low resistance, or I'm sorry, low wattage resistor, and then a high wattage resistor. And in between is this green wire. And the green wire is liable to goes to the volume control. So you have the volume. This is probably the grounded terminal here. Oh, yeah, it doesn't make sense. It's totally backwards. It's totally backwards. Don't know what's going on. I think we need a schematic because the two resistors there and the green wire, I can't figure that out. Let me hunt down a schematic at this point. I'm going to need it sooner or later anyway. Okay, here's the schematic for the radio. What we're curious about right now is what is going on with the cathode here. Actually, it's a grid. Oh, maybe that's my confusion. My confusion here was I was checking out this grid. This is they don't show you the pin numbers at all. So, and then what happened? Then what happened to me? And then I looked from the grid. Yeah, I got myself confused. Look from the grid. I'm looking at through this resistor here, and this is going up to. This must be the B minus. In fact, look at that right out on the plug. Yikes! This is a bit of a danger radio. We'll study a little more in a second. So what I thought I was looking at was the cathode, but I got myself thoroughly confused here. Let me just. While you stare at that, I'm going to take a quick look at the pinout for this, and if I want to check how the cathode is handled, I'd be looking at pin 8. Okay, so let's look on here. The cathode has 100. Now, this is more typical of what I would imagine. Just a resistor here. I was probably seeing. I don't know what the heck's going on. Here's a 0.2 and a 0.2. This is the resistor or capacitor I'm concerned about. May leak voltage into here. That's what we're going to look for. So we're going to want to measure the voltage of the grid here, and also the voltage of the dropping across this resistor, and the measurement of this resistor. We might as well. We can do that now. While we got the schematic up, though, let's look for another thing, and that is how is the chassis handled. And here it is here. So they're showing you the chassis symbol. Here it is here. It only occurs there. This is the one connection from the wiring of the radio to the chassis, and it's through this capacitor. But see how this could be plugged right into the outlet in such a way that this is live. So you have 120 volts right here, 120 volts on this side of the capacitor, and your hand on the other side. So you're depending on this capacitor. Would you get a shock? A 0.025, 120 volts. If you're well grounded and you touch this, you'd probably know it. I think you'd know it. I don't think you'd get hurt. So this must represent the antenna. This would be the additional antenna you might want to add. Oh, this would be for the short wave, actually. That's what this would be, a short wave antenna. It finds a ground through here. It's probably transmitting its signal through this transformer. Where's the grid here? Here's the grid. You switch. You're switching from the AM antenna down to the shortwave transformer end antenna. Okay, that's all pretty straightforward. Is there a wire hanging out the back here that looks like an antenna wire? And yes, there is such a wire. There's another one hanging out the back. There's two wires hanging out the back. One of them has a capacitor. And that wire, that's weird, feeds back into the radio. What's going on there? It's a capacitor up near what must be this coil. I don't know what's going on there. So there's a wire hanging out the back, and there's another wire that's hanging out there, but it's not hanging right out. One end is connected to a capacitor into the radio, and the other end just disappears into the chassis. I don't know what those are. Okay, just lining up things here to be aware of. That's probably all there is that's really important right now. The filter capacitor was a 60 and a 30, and I've put in a 50-50, and what was in there was a 40-40. So it was definitely replaced. So second time around, maybe even the third, who knows, to have the filter capacitors changed. Okay, back to the radio. Okay, first thing we can check is the big resistor here, which is the cathode biasing resistor. And what did it say on the schematic? I've forgotten. Let me just take a peek again. I think it was 150. Yeah, 150. So this should be. How do you get 150 out of that? Should be brown, green, brown, shouldn't it? Okay. Let's read it and weep. You know, this is, look at that, 400. This is installed. This has been replaced. Oh my God, he's replaced it with a crazy size 429. Yeah. What are you supposed to think of that now? So the manual, the tube manual, often recommends the sizes of resistors for different applications. So let's just see if it does that. Typical operation. We'll look over here for ohms. 180 with a cathode with a plate supply of 200, but the plate supply will be less than 200. But they don't give over here because this is a fixed bias. They don't have another. So I don't know. So 180, it says 150 in the on the schematic. This is a far cry from it. This would, what would this do? This would I think this would impede the output quite a bit. See, the thing is, it's a little hard to understand. The grid signal has to go through this resistor too, because the grid signal, the signal you're applying to the tube onto the grid, you're trying to establish a voltage difference between the cathode and the grid. That's what you're trying to establish with the signal. And the resistor is in series with the cathode from the grid's point of view. I know it's a little hard to understand, but the bigger this is, the more it's going to decrease the grid signal, which more going to decrease the output. Not the least of which is it's going to cause a bias voltage to be very different, and generally the current through the tube is going to be way low. So turn up the volume, you may get clipping or something, some kind of distortion happening. Those are all my stories. Let's find out what really happens here. Is there any other measurements I should make before the answer is probably yes, but I won't. Okay, let's turn the radio on, and we're going to switch the meter over to voltage here. And we're going to find out the truth. Here we go. Are we safe here? Everybody safe and happy? Must not be on. There we go. Also measure the B plus. Now we got to find a B minus point. A good one would be right here, just this negative terminal here. Look at these guys are loose. And that's the same as here, which is a really good place to go. Okay, so but we got to read between the cathode and the grid to get a good voltage reading. So I'm going to put this on the cathode right there. I'm going to put this on the grid, which if I remember it was right here. Don't do that. Try that again. So you have minus 8 volts. Minus 8 volts. Damn, I could tell me. Where's my book here? 50L6. Now this is actually a voltage here. So it would be here. Minus 7. Minus 7.5 under fixed bias. And we got minus 8 under the arrangement here. Fixed bias, they're using a very low plate supply. So it actually doesn't seem that bad off to me. We can do the distortion test.
So that's like one little bounce back, and when it comes to the 2025 Blue Jays, a run differential, I think like the one thing that stands out to me are some names, okay? Paxton Shaw, Mason Fluharty, Jacob Barnes, Josh Walker.
Yeah, lots of volume without distortion. Yeah, at the very top there it gets pretty distorted, but and I'm only running this on 108 volts. If I rammed this up a little higher, then we'd probably have a little more headroom in there too. So actually the radio's working quite well, just the way it is. I couldn't claim there's a problem yet. So let's take a look at the grid bias relative to ground, which is almost the same thing we just did, but not quite. So ground is actually B minus, I shouldn't say ground. And the cathode, this might make the radio hum. Which one was it? What's this one up here? I got the volume turned down. There it goes. So we're seeing 0 volts. Very good. What I would be concerned about is if we saw a positive voltage there, it would indicate this capacitor is leaking. In an old radio with an old capacitor here, it almost certainly does leak. Some voltage will get up onto the grid and adjust the bias incorrectly, cause the bias to be different than what it should be. Not the case with this radio. So I think maybe my best move here is leave all this stuff as it is. It all seems to be working just fine. Move on to the alignment of the radio. I just don't think it's worth changing these capacitors out. There's no reason behind it yet. Anyway, okay, power off. Very good. And alignment now. So I had some trouble finding the schematic because I kept looking for a Philco radio, and it's a Crosley, for crying out loud, or a Moffat. Okay, let's read up on the alignment stuff here. I think because my time is so limited this morning, what I'm going to do, what I didn't do yesterday, was check the shortwave band and see what that's all about. So I think I'm going to do that now. And we already know that the AM band is working well all across the band, and it's quite accurate. The dial is quite accurate. A very good sign. This isn't the best time of day to be doing shortwave listening, but we're going to give it a try. So there's a pretty strong shortwave signal available on the end of this wire. I'm going to guess that this is the shortwave antenna sticking out here. Antenna lead. There we go. So some of that signal is making it through to the AM side of things. Okay, shortwave. 6 megahertz. That sounds good to start with, but we shouldn't find anything down here. might start getting stuff up in here, maybe. Depends on the conditions. The I'm picking up is some kind of interference that I regularly pick up. So now we might get a station right around 9.3 megahertz, which is, then again, maybe not. Oh, it's tricky to tune this radio. Coming up in 11 megahertz, there's a broadcast band there.
Ha evolucionado rápidamente en las últimas décadas, desde las televisiones en blanco y negro hasta los televisores OLED de última experiencias visuales más realistas y envolventes. Sin embargo, el de las
Thirteen's a European band. See the noise levels going down. 13 megahertz. Noise level coming back up. You have to tune very slowly.
I can't believe he found them.
He seems sorry.
We very clearly told him not to look up there.
I'm honestly impressed that he was able to do it.
Right? But if he balanced on that big chair, or...
Yeah, I mean, I guess he'll just know what his gifts are this year.
I really thought we didn't.
No doubt that was coming from the United States. Almost certainly a religious based. Don't know what that is. Something in my shop here. And we're getting up towards 15 megahertz. Okay. So the performance of the radio actually is good, even though we only picked up a couple of shortwave stations. There isn't an awful lot out there anymore, and there isn't an awful lot there to pick up at this time of day here at my location. So it actually did a relatively good job. So there's really nothing seriously wrong with this radio at this point. And even performing in alignment is kind of a questionable activity. Because it seems like it's really got a lot of room to go down in performance and not a lot of room to go up. So maybe maybe I'm done. I'm done on this guy. I mean, how much better can it get? That's another question too. How much better can you get it? I don't think much better than it is. Now it was connected to a very good antenna. This is a active antenna outside. It has an amplifier right up in the antenna itself. It's called a mini whip. Produces a pretty good signal all through the short wave, long wave, and medium wave bands. And so if you hook this up to a piece of wire, you might not get the same kind of performance that I'm able to do here. So that's it for today, though, because time has run out, and I have a big day ahead of me. Thanks a lot for watching, and I'll see you in the next video.